Hello, everyone. Welcome to our webinar. Today, the topic that we're going to discuss in our webinar is IEEE P2413.1 and IEEE P2413.2 projects. Those projects belong to the family of IEEE 2413 Architectural Framework for IoT, and they further explore opportunities in the space of developing application-specific and domain-specific frameworks for IoT. So with that regard, I'm not going to bore you with official slides. You can review them later, but please remember that this meeting is conducted in accordance to IEEE SA standards bylaws, and you can review them following those links on the screen. I would like to start by the introduction of our panelists, and each one of us will present and introduce himself or herself to make it easier for you to associate voices with names. So I'll start with myself. My name is Oleg Logvinov. I'm the chair of IEEE P2413 Working Group and CEO of IATECA. Mr. Ning.
Hello, everyone. I'm Ning Xin from the Operation and the Materials Department of SCCC, the Three Great Corporation of China. I am the project leader of several projects in power distribution Internet of Things, such as architecture research and the new product development. I hope through the work of P2413.2, we can share our experience and make contribution to IoT application in power distribution. Thank you.
Thank you very much. Mr. Chen.
Hi everyone, I'm Peng Liming from China Southern Power Grid, and currently we are working on the power distribution Internet of Things. And today we would very be honored to have this opportunity to share with our practices in this field. Thank you.
Thank you very much.
Hello everybody, my name is Xiaoying Yang. I work as a Senior Industrial Solution Manager at Huawei Technology. My background is in power system protection, automation, and communication technologies.
Thank you. Mr. Wang.
Hello, my name is Bruce. I'm from Huawei Technology, and I'm responsible for the smart city and the safe city standards. And also, I'm the editor of the P2413.1 project. Thank you.
Thank you very much. And Mr. Jardim.
Hello, my name is Mario Jardim. I'm from Schneider Electric, France. My background is on systems and power systems automation and cybersecurity. Thank you.
Thank you very much. So today's agenda is quite simple. We will talk about P2413 project family. We'll talk about the update of what work has been done in 2413.1. And after that, we'll have 4 presentations from P2413.2 project. The project has not officially started yet. We just have a call for participation. So pretty soon we'll be holding the first work group meeting. But we thought it would be great to share with you visions of participants and drivers of this project so you can assess for yourself whether or not you would like to participate. And of course, my hope is that your decision will be to get involved with this project. And at the end, we'll leave a few minutes for Q&A. But in any case, you will be able to ask us questions whenever you need to. You know how to find myself, and I'll be happy to link you with other members of this project. So first of all, let's talk about cross-domain nature of IoT. This picture is taken from IEEE 2413 standard. And this picture essentially is an illustration of how electrified and autonomous transportation is really a component that belongs to multiple domains. It belongs to the communication domain, it belongs to the roads, it belongs to the infrastructure, it belongs to the power grid, smart cities, buildings. So effectively, we have a platform on wheels that has sensors and data embedded into it. And those sensory expressions belong to a multitude of domains. So we need to leverage them, not just in a single control system, not in a single automation system like it used to be in legacy devices, but we need to be able to leverage it across multitude of domains such as smart cities, smart buildings, power grid, communication, infrastructure, physical infrastructure, and find a way to derive knowledge and value from the information that we can expose from this electrified and autonomous transportation platform. So that's a very simple example of cross-domain nature of IoT. And in fact, that was something that motivated the creation of IEEE 2413 standard for an architectural framework for IoT. If you look at this somewhat complex picture, the purpose of it is to illustrate that IoT domains are numerous. And we just have a few examples here: smart manufacturing, smart grid, smart building, intelligent transportation systems. We have smart cities, healthcare, but the list it really goes on. It cannot be possible to count how many IoT domains we have today. But what is the commonality? How can we create an architectural framework that links all of those domains and helps us to leverage knowledge that we can put into the designing each one of those domains to use in other domains? Well, we decided to follow the approach 42010 standard, which basically creates a tool for defining architectural frameworks. And this tool is based on definition of stakeholders and concerns. And from them, you can derive the commonality of concerns and stakeholders that can be then created and implemented as views driving the development of the architecture. If you look at this picture, the whole purpose of this picture is to illustrate how an IT architecture is created, leveraging this view catalog, viewpoint catalog, and creation of the views. And what we have done in the standard is actually creating this overall overarching architectural framework that defines a unified approach to the definition domain specific architectures. The standard was approved last year, and you'll probably be able to download it pretty soon from IEEE website. And that led us to the conclusion that we need to start the work on the next generation of the standard. And the first silo, the first domain that we wanted to attack was smart cities. That was the birth of the 2413.1 project. The second was smart grid, and that is 2413.2 project. So if you think about from the development process point of view, we first came out with a fundamental architectural platform and then started drilling down, defining architectural frameworks for specific domains and specific verticals, such as smart cities and smart IoT for power grid. In this case, 2413 PAR was approved in June 2018, and PAR for 2413.2 was approved in November of 2019. So the groups for 2019 project, 2413.2, will start meeting this year and we'll start sending invitations. Most likely our first meeting will be an online meeting to make it easier for everybody to participate. Well, with that, it's time for us to start talking about what those projects will be about. First, I would like to provide Bruce with an opportunity to give us an update on the 2413.1 project. Bruce? Welcome.
Yeah. Okay. Hi, everyone. Actually, we are here is evening. For you, I think it's morning, right?
Correct.
First, I will introduce the P2413.1 project. Actually, this project is focused on the smart city. But you know, smart city it covers many aspects, especially for the IoT part. So this project is based on the IoT standards P2014, and also we will develop this standard um, for a reference architecture for smart city. As we know, smart city actually has so many industries. So for this project, we mainly focus on the common features and the common platform across the different domains and provides a basis for all of the industries. So based on this requirement, that means we need to cover the requirements from governments, enterprise, and consumers. So that means a variety of smart city applications will be derived to create the greatest social value. Okay, next page, please. Actually, for the past 2 years, we already done some work. For example, here is the architecture proposal and development. Based on the discussion, we already done the new SD capabilities. For example, the IoT video, unified connectivity, and the architecture already discussed. What we have done is mainly focus on the North API and the source interface because the platform is complex and there is no unified proposal from different SDOs. That means every organization has their own understanding about this architecture. So first, we need to unify the features of the platform. That means first we need to cover the same ecosystem. That means the same API and the same applications can be used across different platforms, especially across different vendors. So here we provide this architecture to define the unified APIs, especially in the South and the North APIs. But for the modules of this platform, it's still under development. So we are really welcome everybody, and more company can be involved in this process. And because this is we already output some drafts, and we need more people and companies to be get involved to discuss this project. Also, as we know, the standards must be for the industry and for the governments and all the consumers, also for the application developers. That means we need to build an industry ecosystem. So for the P2413.1, we just build a common platform. In this project, we will address different requirements from different industries. For example, the smart city digital transformation and the smart campus digital transformation, also smart airport and the public safety, and also the others all this. But here is we only address the requirements, and we will get the abstraction of the common features. But for every industry, we will find the corresponding standard organizations to develop the corresponding standards. Here, we only define the reference architecture. Okay, next. Okay, that's all. This is the overview of the P2013.1. Just as I introduced, this project is still under development, and we just developed some modules and some common features and common platforms. But all of this is just a draft and is a proposal. So we hope everybody can be involved to contribute your proposal and your ideas, all of this to, and then we can complete this project. Thank you.
Thank you very much, Bruce. And I would like to echo Bruce's point. Welcome to Get Involved. We will be announcing the next meeting of 2413.1 and 2413.2. Welcome to participate. Welcome to contribute. Welcome to bring your thoughts and contributions. It will be greatly appreciated to have additional content in this project. So with that, let's transition to P2413.2. Let's talk about power grid. Mr. Ning, would you like to start with your presentation?
Can you hear me?
Yes.
Hello, everyone. I'm Ning Xin from Secret Corporation of China. My presentation is about IEEE application of Internet of things in power distribution. Next page, please. My presentation will include three parts: background, architecture, and components, application and use cases, which is about nodes, products, and several use cases of PD-IoT as example. First, I will introduce the background briefly. Our electric power system consists of 5 parts: generation, transmission, transformation, distribution, and consumption. Power distribution system is located at the end of the power grid, which directly affects the reliability and the quality of power consumption. Distribution network outages account for more than 90% of total system outages. There are low or no visibility and controllability of distribution network equipment. The increasing penetration of DER, ES, and EV charger in the power grid also bring the challenges to distribution system. So, upgrading and routing in this part may directly improve the customer experience. And that is why power distribution Internet of Things is proposed. Next, please. This solution is a highly flexible and intelligent power distribution network. It provides a platform with built-in situational awareness, flexible data management tools, machine learning capability, and software-defined applications development. It consists of 4 important parts: cloud, network, edge, and the terminal. Cloud is a master platform. It adopts SDN architecture and provides distribution management devices. Network provides data exchange between the cloud, edge, and the terminal. It is a communication network for consolidating and exchange massive data. Edge layer is a distributed intelligence agent close to the data source. It provides local computing and analysis functions. Smart distribution transformer terminal unit is one of the edge computing products. I'll introduce it later. Terminal provides the awareness of power grid to the edge or to the cloud, such as operating status, device status, environmental status, and other information. It is also responsible for executing the controls. Next, please. We have a key node products, a key node produced, and several use cases of PD-IoT example. With a massive access of various terminals, the traditional TTO shows many shortcomings in configuration and maintenance. So, we designed an edge computing nodes product deployed near the transformer. Smart Distribution Transformer Terminal Unit, or SDTTO for short. It can perform local management in the low voltage area and the distribution transformer. The SDTTU can be used to collect and manage the data from distribution transformers, smart switches, meters, and other devices. It can also perform real-time data exchange with the cloud. Up to now, this product has been installed in more than 32,000 distribution transformers to support the grid operation. Next, please. Next, I will explain how it works by two use cases. These are not only the function of course, but just give everyone some examples. The first application is plug and play of low voltage devices. With the massive access of terminals, manual configurations is time consuming. The traditional way of configuration costs about 2 days on average for all the low voltage devices and their transformer. However, if the low voltage devices can be plug and play, the configuration can be much faster. The device can achieve self-discovery and self-registration when it is powered on. When the phone scans the code, pattern association can be completed at the same time. So the master station can quickly locate the device in topology. In this way, the installation time can be limited to less than 2 hours per transformer. Next, please. Another achievement is about outage reports. With SDTTU, we are able to monitor the low voltage area more frequently. The data can be analyzed in SDTTU, and only results are reported to the cloud. The user will be notified by message when the repair work starts and completed. As a conclusion, with SDTTU, we are able to improve the accuracy of judgment information, reduce investments in communication computing resources. Next, please. So, this is all about what I want to share with you. Thank you for attention. Thank you.
Thank you very much for your presentation. And with that, we will move to the next presenter, Mr. Chen. You might be muted, Mr. Chen.
Sorry, I'm muted. Sorry. Thank you, Alex.
Not a problem.
Oh, sure. Thank you. And hi, everyone. I'm Chen Liming from China Southern Power Grid. And today I will share with you the practice of power distribution Internet of Things in China Southern Power Grid, CSG. Next page, please. I will limit myself in 3 parts: the construction approach, construction practice, and next steps. Next page. First is the background. In May 2018, CSG proposed the construction of digital power grids, and we even established a new research institute to facilitate the transformation. And as can be seen in the left picture, the lower part is our physical power grid, which includes the all kinds of power grid equipment and devices. And in the upper layer, it is the digital power grid, which consists of all the data and operation services. And the connection between the physical and the digital power grid is the all-domain IoT platform. And this platform is the important basis for company-wide digital transformation. We designed this platform to effectively connect devices, collect and share data in all service domains, detect status, and integrate novel services. This platform is built to achieve the unified connection, collection, and management, unified model and sharing, so as to achieve the ubiquitous perception, efficient connection, and convergence and innovation. Next slide, please. And this picture is our roadmap to construct the PDIoT platform. We built this platform so as to integrate monitoring, warning, analysis, decision-making, and command, so as to improve the distribution network. And the comprehensive monitoring and command capabilities, transparent operation and management, and the improved power supply reliability and management are also our aims. There are 4 layers of our PDIoT, as you can see in the picture. From up to down is cloud, pipe, edge, and terminal. Next slide. And second part is our construction practice. We have done many pilot projects, some even at a very large scale. And here we only choose 5 typical scenarios that may be useful to share with you. And the first practice is the construction of intelligent power distribution rooms in Guangdong, Guangxi, and other provinces. Since 2018, power distribution IoT constructions has been implemented in CSG. We started the development of intelligent power distribution rooms construction program based on the simple, economical, secure, and effective IoT platform. Simple means to achieve full application of intelligent technologies and simple architecture. Economical means unified construction of the platform layer and application layer. Secure refers to the fact that we have security design for services, platforms, access, and also sensors. Efficient means we design the interconnection with the power grid management platform and the data convergence application. We developed intelligent power distribution gateway as we can see in the middle of the right picture. It could converge metering and device monitoring, convert sensor data of different protocols into IoT protocol, and then sends all domains IoT data to the cloud platform. Next slide, please. And our second typical practice is to build all-domain IoT platform in Hainan province. And this platform is developed to facilitate unified access to data in various service scenarios, not only in grid, but also refers to the smart city, such as power distribution room, intelligent monitoring, optical storage charging, a smart traffic lamp, and cable temperature measurement. And all the data connected would connect to the digital power grid platform and the Boer Smart Grid International Forum exhibition hall in a real-time manner. Next slide, please. Our third typical practice is the online monitoring of distribution network cables. We constructed a cable monitoring system for power distribution cables in several big cities like Guangzhou and Shenzhen or Foshan. And the signals data at both ends of the cable are collected, and the differential algorithm, rule knowledge base, and big data technologies are utilized to accurately predict the potential weak points of the cables, and further to quickly and accurately locate cable faults. Next slide, please. Our fourth typical application is the fault location of the overhead line. Fault location system of overhead line is constructed by using high-frequency recording sampling on the three-phase line of distribution network. The feature data of the running status of the overhead line is extracted, based on which real-time online monitoring, fast fault location, and intelligent statics analysis of fault events are then achieved using big data analysis. Next slide, please. And our fifth typical practice is the intelligent monitoring of low voltage distribution network. Here we use hybrid PLC technology to enhance data connection capability of the low voltage power distribution network. Several pilot projects are conducted to verify the functions of proactive reporting of power failures, intelligent topology identification, terminal voltage monitoring, and three-phase imbalance monitoring. Next slide, please. And here is our next steps. First, it is our understanding that PD IoT construction is only a mean, but not an objective. The objective is to solve core problems in distribution network production management, as well as operation and maintenance through IoT technology. And in future, we would strengthen the ties between research and industry to facilitate application of key technologies in PD IoT. And also, we would enhance the hierarchical design of PD IoT, such as cloud-to-edge synergy. And further, we would develop modularized architecture to promote rapid and flexible implementation concerning different service scenarios in different places. And that is my sharing. And thank you very much. Thank you.
Thank you very much. It was a great presentation.
Thank you.
And with that, I would like to move to our next presenter, Mr. Jardim. Mario, please unmute yourself.
Hello. So I hope you can hear me now.
Yes.
Okay. So we are going to talk about what is our perspective from electrical energy distribution point of view. So if you could share the next slide, yes, please. So we are looking at IoT technology that's emerging that can bring in to existing solution lots of benefits. We would like to use this technology on current solutions and deploy it in a smoothly way, creating a forward compatibility so we can pave the road to have deployments of new innovation on the existing infrastructure. All of this with the intent of assure to customers that be investing and have made those assets protected and controlled using IEEE 62050 standard compatibility and evolution capacity. So we want to make sure that there will be a transition, a smooth transition or merge of technologies capable of producing more value to current and future infrastructures. So to do so, we believe that we have to keep improving interoperability at different layers. It's one of the major goals that we have for the past years, and we want to continue in that direction since results were there. Both were based on IEEE 62050 series and SIM standards. So here we really looking at communications, data models, and applications. So we want to make sure that those layers can be interoperable and we can have this capacity to evolve fast and with different timeline for technology. For all those things to be true and to happen, we think that this can contribute a lot to the life cycle interoperability of those solutions. We believe that there is a lot of improvement to be done, and IoT is the typical type of technology that can help a lot and can help a lot on the maintainability of current and future solutions. So this is really one path to go forward. On top of this, and this evolution that we foresee happening in the type of solutions that we are deploying, we want to make sure that this remains safe and secure. So we want to continue to deploy them using the energy standards that we are using everywhere. Basically, the ones related to 27 series 62443 and 62451 that are today the core of the applications that we are currently deploying. So that's what I wanted to share with you today.
Okay, can you guys hear me, Oleg?
Thank you very much. Yes, Ms. Young, you
Okay,
are
great.
going to be next. The microphone is yours.
Yeah, okay, thank you. Oh, sorry, you guys were not able to hear me earlier, but it's good now. So let me get started with my presentation here. First of all, thank you for the opportunity. As one of the initiators for this IEEE P2413.2 PDIoT standard, it's a great pleasure to have the opportunity to introduce you to the scope of the work, and then I welcome you to join us, and then welcome your participation. So next slide, please. Next slide, please. Okay, so first of all, we do look into the power distribution side, and then we see a lot of challenges that we in the distribution side. In summary, the challenge we're seeing in the distribution grid is that there is a vast amount of equipment and IEDs and sensors, and there's a lack of development in distribution grid in general. And then distribution grid fault takes significant labor hours to identify and restore. And in general, the distribution grid, we're looking for economical solutions. In this case, a platform solution for agile application development, as well as migrating existing applications to such platform. Also supporting new business cases, such as supporting the management of renewables and electric vehicles. Next, please. So what does the distribution grid need? Summarized here is that first it needs a connectivity, that we need to connect a vast amount of distribution grid equipment sensors and then even home sensors from individual homes, and to gain panoramic situation awareness. And then we'd like to provide predictive maintenance based on big data and AI capabilities. I'll mention that at later slides. And then we'll want to have a plug-and-play device installation, maintenance, and repair. And then the distribution fault fast identification, isolation, restoration. And we look for to support this, we look for agile application development to support this vision and support new business models. Next. Okay, so we see that the power distribution IoT architecture comprises of 4 key components. One is the terminal, pipe, edge, and cloud. Pipe represents the communication technology or the communication channels. The terminal side, we're seeing that in this terminal needs to be have a OS to support the services such as plug-and-play services. This plug-and-play services is a collaboration between the terminal, edge, and cloud. We also see the edge needs edge computing power to support local autonomy or like near real-time or real-time decision analysis and decision making. At the cloud level, we see that we need a software architecture that will be able to support migration of existing applications, and then also supporting new application development and then fast iterations. Next. Okay, so here's a more detailed look into these 4 key components and what it corresponds to in our grid. So on the sensor side, it could be meters, could be protection IEDs, switches, PV panels, and then all this equipment is part of the sensors and terminal layer. And then the intelligent gateway should have the computing power, like I just mentioned, be able to support near real-time or real-time controls, and then monitoring as well. On top of that, the information is fed into a unified IoT platform that supports aggregation, data aggregation, and data management. On top of that, there should be standard interface to interface with to support software companies to build and develop applications on top of this platform. Next. So for the IoT power terminal, we see that should support features such as plug-and-play services to minimize the effort for installation and maintenance, and the standard management, and then also support standard communication stack. And it should probably also inherit current IEC standards as well. Then support rapid growth of low voltage equipment ecosystem. Next. Okay, so on the edge node side, it's important to emphasize that it should support agile function development. In this case, we see that the hardware should be hardware and the software to be decoupled. Hardware serve as a platform and software serve as a platform. On the hardware side, we do see that there are standard communication interface such as 3G, 4G, and 5G, and PLC, RF, and then RS-485, 232, and so on. On the software side, it's adopting a container-based technology to support agile application development and then also application updates on the edge node as well. Next, please. Okay, so let's take a look at the applications that we mentioned about on the IoT platform. So we've seen that for legacy systems, we see that the legacy systems upgrade process are usually very cumbersome, often require system level updates. Application and system are coupled with vendors. Many utilities systems are in silos, and then a lot of the data are represented using point list. And the lack of full cycle asset management and so on. So on this PDIoT architecture, we would like to see the following characteristic of this PDIoT applications, that it should support independent application updates, vendor independent applications, and flexible application customization adoption, and then self-descriptive data models. And next, please. Okay, so for the communication side, we do see that there are different scenarios across the distribution grid, and there's different communication technology will be able to meet the requirements for different scenarios. So there will be wire and wireless communication, and then like I already mentioned, 3G, 4G, 5G, PLC, HPLC, NB-IoT, and so on. Thank you. Next, please. Okay, so here I would like to show you an example that was finished in early May in 2019. It was a pilot project, but it was deployed at much larger scale since then. But basically, there are some key features that accomplished using in this example here, adopting the PDIoT architecture. One is that the terminal and edge computing node, they supported plug-and-play installation at the terminal level, and supported local intelligence and agile application development at the edge node, which is the intelligent gateway. And now on the cloud-based master station, it supports the plug-and-play device registration and monitoring a vast amount of sensors and IEDs. And it also supports distribution network topology management. It has standard RESTful API to support multi-vendor agile application development, and it has libraries of dashboard templates and so on. Next, please. So I summarized the market potentials for this IEEE P2413.2 standard. And then you should be able to get this presentation after this meeting. And then I will be happy to answer any questions that you have. Next. Thank you.
Thank you very much for a great presentation. And with that, I would like to ask if audience has any questions. We have about 10 minutes left till the end of this webinar, and we can take a few questions. Well, if nobody has questions, I actually have one.
Hi, everyone. Can you hear me?
Yes.
Hi, good morning or good day, everyone. This is Gabriele Weber speaking. I'm working for Nozomi Networks. It's an organization busy with cybersecurity in the OT and automation world, and now we're moving also on the IoT side. And I'm here as an observer to for interest in the work you are doing. Thanks for all your presentations. I have a couple of questions. One is Mr. I think Mario Hardim from Schneider Electric. He mentioned 62351 as a connection, let's say, with the work you're doing. I've been an active member of 62351 in the last years. So I was wondering how he sees the connection between the work you are carrying out, and that standard 62351.
Maria, would you
Hello.
like to answer?
Yes.
Nice to meet you,
I
Maria.
can answer. Nice to meet you. I am also part of 62351, but not as active as part of other organizations as well. But we today 62351 is the reference for type of systems that we are deploying, as I mentioned, and well, we use actually the reference coming from 62443 and the context defined in 62443, and then the technical means and the infrastructure is coming from 62351 for security communications and, for example, PKI and this type of things. So I believe that the work that's carried out on 62351 today is as generic as possible. It's covering many OT protocols that are today used in many automation systems. So as a consequence, this type of standard has to be part of the study that we are going to carry out for this particular case. So I think this is something that we should incorporate into it and make sure that we have the compatibility, as I mentioned on my presentation, because it's going to solve and solve problems and actually increase the security of our solutions.
And I would like to add to what Maria said. Gabriel, what we have done when we were developing 2413 standard is we have established a lot of liaison relationships with organizations like, as an example, Industrial IoT Consortium, IVI group in Japan, and the list is actually quite long. That allowed us to put a lot of very valuable input into the creation of the document that became the standards that we published. And I think it probably merits potentially creation of the liaison relationship with the group you referenced, because it sounds like there could be something valuable that can be brought in.
For sure, thank you. And
I think so. I truly believe that there is a lot of valuable work today at 62351 level, and this work is made for energy systems. So basically, us manufacturers are deploying solutions that are based on that, and there is we should use this type of technology because it's going to make us move faster and more compatible. So it's just a good thing to happen.
Well, to me, it sounds like we have our first action item.
Okay, so and to connect to what you said, Oleg, about your liaisons or connections to other works that are being carried out, have you heard of this joint technical committee between IEC and ISO, and it's called Subcommittee 41, and then is dedicated to Internet of Things and related technologies?
We're also a member of that as well.
Yes, in fact, we collaborated with this group quite substantially when we were developing 2413 standard, and I believe we have still an active liaison agreement with this group.
And how are the two works different? Do they overlap? Is the scope different? I'm just entering in this let's say context word now, so I still have not clear what can be the overlap or not between the two groups.
Well, C41 actually was formed when we were almost finalizing our work, and our liaison officer between the two groups was actually a gentleman from NIST, National Institute of Standards here in the United States. So he did a lot of work conveying information back and forth between the two organizations. I think when we talk about 2413.2, it's a more specific domain, which is related to power distribution IoT. But I still think that there could be a lot of value by linking again with SC41 work and examining what could be essentially common, what could be enhancing, and what could be expanded in respective work. I truly believe in the unification. You know, somebody had said many years ago, right? The beauty of standards is you have plenty to choose from. That's not always good. So unifying standards and building bridges among them, to me, is very important. We should not be trying to reinvent the wheel unless it's absolutely necessary.
If I understood correctly, this group didn't meet live yet, did it?
No. This is pre-kickoff meeting, and the purpose of that was to essentially give a little bit of a preview of what work will be contributed into this effort and what will be essentially the direction, so people who are interested, like yourself as an example, can form an educated opinion if you should join this group or not.
Right.
Just to add something to the discussion, I am also part of the PSCC, so it's the inside IEEE, which is taking care of communication cybersecurity. So there is on the roadmap of the group some more in-depth understanding of 62351 in the context of IEEE. So there's a liaison over there, and there's a willingness to explore even further IEEE of IEC 62351, just to make a parenthesis.
That's a very good input, very good input. And I'm actually glad to see that the purpose of this webinar is essentially to establish connections to other organizations and build bridges is working. We're already discussing practical action items towards that. That's fantastic. That's a great achievement. Any other questions, comments? Well, if not, I would like to thank everybody for participating in this webinar. Tremendous job done by presenters. You deserve a great round of applause. Thank you for your work. Thank you for your contributions. I look forward to kicking off this activity at the first work group meeting. Please stay tuned, look for the announcements. We will probably host our meeting within the next 30 to 45 days, depending on how worldwide conditions will allow us to do so. But we definitely look forward to kicking off this effort and continue down the path with 2413.1 as presented by Bruce. Thank you very much again. Thank you for your contributions. Thank you for your
Thank you.
attendees. And thank you. We look forward to
Thank you.
collaborating with you in the future.